Hello students, welcome back to our online bridge course classes. In the previous video, we have discussed in detail introduction to the optics, definition of light, properties of light. Those are reflection, refraction, diffraction, dispersion and interference briefly. In this video, we are going to learn the topics. Those are definition of a wave, properties of waves, which are wavelength, amplitude, displacement, frequency, time period, and velocity. Also, we are going to discuss the types of waves. Now, let us start with the concept wave. What is a wave? Wave is nothing but it is the disturbance set up in a medium. Waves carry a particular energy. So students, a wave is nothing but an energy disturbance created in a medium. It carries a particular energy unless and until the energy is distributed in the medium. In the first image, you can observe that there is a disturbance created on the water surface. This is called as wave. A wave is nothing but the disturbance in this water medium. In the second image, you can observe a wave in the form of sound. So sound is a form of energy. So sound waves carry a particular energy. In the form of sound waves, the media transfers the energy from one place to another place. Hence, sound waves is the energy transformation from one place to another place so that we are able to hear the noise, music, voices, etc. Therefore, wave is nothing but it is the disturbance created in the medium. Also, waves carry an energy. A wave is nothing but an oscillation, which is nothing but a disturbance that travels through the space and matter. Wave motions transfer energy from one place to another place. For example, there is a ripple on the surface of the water, which is a disturbance created in the water surface. Here, the water surface is redistributed with the energy because of the disturbance. So these ripples on the water surface are called waves. The second example is vibrations in a guitar string. If you pluck a guitar string, there is a vibration and hence formation of the sound. This sound wave in the form of energy is distributed from one place to another place and hence we are able to hear the music of the guitar. So dear students, the vibrations created in the guitar are nothing but the sound waves which enables us to create the music. So these are the examples for waves. A wave may be in the form of sound, light, electromagnetic radiation. Now, let us discuss the properties of wave one by one. The main property of a wave is its wavelength. So, what is a wavelength? As you can see in the picture, the wave is traveling in the sine form. The highest peak of the wave is called crest, and the lowest peak of the wave is called as trough. The distance between two consecutive crests or two successive troughs is known as a wavelength. You can clearly identify the distance between two crests in the image. So this distance is known as its wavelength. So dear students, wavelength is the distance between two crests. A crest is the highest peak of the wave. Also, a wave is inversely proportional to the frequency. We will learn frequency in the next slide. Here, as the wavelength increases, the amount of frequency goes on decreases. So, the wavelength and frequency both are inversely proportional to each other. This is the first property of the wave. The second property of the wave is amplitude. What is an amplitude? It is nothing but the measure of the height of the wave. As high of the wave is called as amplitude. It is the measure of the highness of the wave. The amplitude of a sound wave can be defined as the loudness, which is nothing but the highest volume of the sound wave, is called amplitude. The amount of maximum displacement of vibrating particles of the medium from their mean position when the sound is produced is called amplitude. So, amplitude is nothing but the highest noise or the loudness, or also it is defined as the maximum displacement. So, maximum displacement in the sense the shift of the particle from its mean position to its highest value, highest point. So, the highest value or the maximum displacement or the height of the wave is called as the amplitude. It is the distance between crest or trough and the mean position of the wave. You can observe in the image the height of the wave is mentioned as the amplitude from the mean position. In the second image, you can observe that there are two types of amplitudes. Those are positive amplitude and negative amplitude. The height of the crest is called as positive amplitude and the height of the trough is called as negative amplitude. The third property of the wave is the displacement. Already we have discussed. So displacement is nothing but the shift of the particle from its mean position. Also, it is the measurement of distance of the movement of sound particle from its equilibrium position in a medium. Say for example, the sound particle is situated at the x-axis, which is called as mean position, or also it is called as equilibrium position. If it shifts to the y-axis of the length 3 units, then the displacement is of about 3 unit. So, the distance moved by the sound particle from its mean position is called as displacement. So, the how much amount the particle displaces from its mean position is known as displacement of the wave. Now, let us define what is frequency. The frequency of a wave is the number of waves that pass a fixed point in a given amount of time. Consider a fixed point and count the number of waves that pass through that point in a fixed amount of time. Say, for example, you have set 5 seconds of time and you are going to count the number of waves that are passing through that point for 5 seconds. For 5 seconds, if the number of waves that are passing through that point are 10, then the frequency of that wave becomes 10. You can observe in the image, I have differentiated high frequency and as well as low frequency. So higher in the frequency in the sense there are more number of waves passing through a fixed point in a fixed amount of time. Similarly, if the number of waves goes on decreases in that given amount of time, then it is low frequency. If the frequency lies in between high and low frequencies, then we call it as mid frequency. The SI unit for the measurement of frequency is Hertz. Now let us define the next property. A main characteristic of this wave is time period. The time period of the wave is defined as the time taken to complete one cycle. So, the one cycle meaning itself has a great complication. One cycle is nothing but the particle starts at the one point and travels, vibrates and reaches the same point or same height. Then it completes one cycle. Also, one cycle is defined as included as one crest and one trough. If the wave suffers one crest and one trough, then we call it as one cycle. The time taken by the wave to complete one cycle, that is, the time taken by the wave to complete one crest and one trough, is known as time period. Time period is the reciprocal of frequency. If the frequency goes on increases, then the time period of the wave goes on decreases. The time period of the wave is the total time taken by the particle to complete one cycle. The next characteristic is wave velocity or simply velocity. Wave velocity is the distance traveled by the particle per unit time in a particular direction. So, dear students, a wave velocity is a vector quantity. A vector is having a particular direction, and hence wave velocity is nothing but the distance traveled by the particle in unit time in a particular direction is defined as the wave velocity. Wave velocity is also known as phase velocity because all the particles in a wave are having the same velocity. You can observe in the image the relation between velocity, wavelength, and frequency is V is equals to lambda into F. Here, V is nothing but wave velocity or phase velocity. Lambda is the notation of wavelength and F is the frequency of the wave. So if you multiply wavelength and frequency, you get the value of wave velocity. You can also observe in the image that the wavelength of the wave is 3 meter and the frequency of the wave is 2 waves per second, which means that for 1 second the fixed point suffers 2 waves. Hence, if you multiply those two values, 3 into 2, that is 6. 6 is the value of the velocity. The unit for the measurement of velocity is meter per second, and hence in the image the velocity of the wave is 6 meter per second and the unit of wavelength is meter. These are the characteristics of the waves. Now let us go to the types of waves. The types of waves are mainly classified into 3 categories. Those are mechanical waves, electromagnetic waves, and lastly matter waves. Further, the mechanical waves are again classified into longitudinal wave and transverse wave. The electromagnetic waves are again classified into microwaves, radio waves, X-rays, UV rays, etc. This electromagnetic wave has a broad spectrum, which is a very vast topic. Lastly, a matter wave. So, you have to remember the types of waves. Those are mechanical, electromagnetic, and lastly, matter waves. In this video, we have discussed the topics. Those are the definition of wave. So, what is wave? Wave is nothing but the disturbance created in the medium which carries a particular energy. We have discussed briefly the properties of waves. Those are wavelength, amplitude, displacement, frequency, time period, and lastly, velocity. Also, we have discussed briefly the types of waves. Thank you.